ladies and gentlemen. We are going to do 4.2b today, which is a little bit more information about our quadratics. So this is more information about our quadratics. Okay, quadratics represent something that we will do a lot in Algebra 2, so we have to spend quite a bit of time learning how to manage them well. Alright, so I'm going to jump right in to a little bit of review from 4.2a, or the first 4.2 video, by just doing a couple of examples, just to make sure that we have that concept set in stone. Alright, so my first example, so it's going to be example 1, is y is equal to x minus 2 quantity squared plus 6, and I want you to put it into standard form. So the first thing that I need to do is I need to distribute this, so I'm going to manage that in my little box. Okay, so this is the x minus 2, and this is x minus 2. When I multiply to get my cells, this is x squared minus 2x plus 4, because two negatives make a positive. My like terms are situated along the diagonal, which means this becomes x squared minus 4x plus 4. Now I need to substitute this into the equation, so I'm going to get y is equal to x squared minus 4x plus 4, and then there's the plus 6. Combine like terms, and I get x squared minus 4x plus 10, and then that's my answer. So that would be my quadratic equation in standard form. So now I'm going to do another example just to make sure we have this, because it's a really important concept. So again, I'm going to be given an equation, so it's going to be y is equal to a negative 3 times x minus 3 and x plus 2. And again, I want to put it into standard form. Right, so I'm going to put this quadratic into standard form as well. I still need to manage the distribution first, so I'm going to do it in my little box over here on the side, and I'm going to have an x minus 3 and an x plus 2. It doesn't matter which of the two factors you put on the top or the side, kind of whichever way you write it, it will turn out the same. So I'm going to do x squared, 2x, minus 3x, minus 6. My like terms are along the diagonal. So I'm going to get x squared minus 1x minus 6, and I need to take this and substitute it into my equation. So it's going to become y is equal to a negative 3. Here's the x squared minus 1x minus 6. I'm going to distribute my negative 3, and I'm going to get y is equal to a negative 3x squared plus 3x plus 18, and that would be my answer. So the box is a great way to do the distributive property. You could do FOIL if you like FOIL better, but I tend to think that this is a little bit easier. Alright, so now we're going to pause your video, or you should pause your video because I'm not going to pause, and you're going to do your first problem. So this is problem number 1, and I want you to write the quadratic in standard form. Okay, so I want you to write your quadratic in standard form. So the quadratic that I'm going to give you is 3 times x minus 3 quantity squared minus 12. So you'll pause the video and you'll do your first problem. Remember to do your problem on a separate sheet of paper, because you're going to turn that paper in to me when you come to class. Alright, so now we're going to start our one tiny little piece of new material. We've actually already talked about it. You already know how to do the math, so we really don't have much information to learn that's new. if I'm given a parabola, and let's say that parabola is pointing up, which means that A would be greater than 0, and I know there's my vertex, and this is my y-intercept. The vertex becomes the lowest point on the graph, so we say that that is a minimum value, or you could say it's an absolute minimum, meaning that none of the values will go below that point. Okay, so that's if our A is positive and our parabola points up. So then if I have a parabola and my parabola is pointing down, again, this is going to be my vertex, and this little guy right here is my y-intercept. Because the parabola is pointing down, I know that A is negative. The vertex then becomes the highest point on the graph, and so it actually becomes a maximum. So what questions we'll ask you to determine now is, does the graph have a minimum value or a maximum value? And then they're going to want you to find that value. The vertex, if you'll remember from the information that we learned yesterday, has coordinates hk. And remember that my h is equal to a negative b over 2a, and I know that k is equal to f of h. So we already know how to do this math. The only thing that's really new is talking about whether my graph has a minimum value or does my graph have a maximum value. So that's what we're going to do now as we do an example. All right, so let me turn my page. All right, so for our first example, we're going to do example number 3 in case you're tracking your examples in your notes. Okay, so for example 3, I want you to find the maximum or the minimum value of the quadratic equation. Alrighty, so I'm going to give you a formula. My quadratic equation is going to be x minus 6 quantity squared plus 3. So just like we've done in all of our other problems, we're going to evaluate it before we start doing math. I know that my A, even though it's 1, is positive, so I know that A is positive, so I know that my parabola turns up, which means that the vertex is going to be a minimum. So I know that my vertex is going to be a minimum, N-I-M-U-M, sorry, spelling error. All right. So now I need to find the coordinates of the vertex to know what the value is, because it said find the value. So I'm going to find my vertex, which has coordinates hk. My h is a negative b over 2a, and then I'm going to know my k is equal to f of h. But my equation is written in vertex form, so I already know the coordinates of my vertex. So I know that my vertex is going to have coordinates 6, 3. Remember, if it's inside the function, it's the opposite value. So I know that my vertex has coordinates of 6, 3, and it's a minimum. And then I'm done. So I actually didn't have to do any math because they gave me the equation in vertex form, which is very nice. All right, so then let's do another example. So my next example, same directions, so find the minimum or the maximum value. Okay, so it's the same directions, and I'm going to have a different equation. This one's going to be y is equal to a negative 2 times x minus 3 and x minus 5. Now the issue with this one is they gave it to me in factored form, so I actually don't know the vertex like I did in the previous problem, but if I convert it to standard form, then I can find the vertex. So if I critique my function, my a is a negative 2, so my a is negative, and I know that my parabola is going to be turned upside down, which means that my vertex is going to become a maximum. So let's first put our equation in standard form, and then we can find our vertex h and k. So first I need to distribute, and I need to distribute x minus 3 and x minus 5. I'm going to get x squared minus 5x minus 3x plus 15. My phone's ringing, so we're just going to ignore it. This simplifies to be x squared minus 8x plus 15. So you have a little background music as we do math. I need to substitute this into this equation. So I'm going to get y is equal to a negative 2 times x squared minus 8x plus 15. If I distribute the negative 2, there we go. I get a negative 2x squared plus 16x minus 30. So that's my parabola in standard form. Now I can find my h and k for my vertex. So remember that your vertex has coordinates hk. H is going to be a negative b over 2a. Okay? So if I substitute my values in, I'm going to get a negative 16 over 2 times a negative 2, which is a negative 16 over a negative 4, which yields a positive 4. Now I'm going to substitute this value back into this function. So my k is going to equal f of 4, which means I'm going to substitute the 4 into the original function, and I'm going to get a negative 2 times 4 squared plus 16 times 4 minus 30. So then I get a negative 2 times 16. 16 times 4 is 64 minus 30. So that's going to give me a negative 32 plus 64 minus 30. Simplify just a little bit more, and I get a negative 62 plus 64, so I get that my k is 2. So now I can answer the question that they asked. I have a maximum value, and the value of that maximum point is 4, 2. And this is my answer. So I have a maximum value, and it occurs at the point 4, 2. All right? So now we're going to pause, and you're going to do your second problem. So this is going to be problem number 2. So once I get it written down, then you're going to pause the video, and you're going to do your second problem. It says to find the minimum or maximum value of a function. All right, so I'm going to find the minimum or maximum value of the function. I'm actually going to give you two. So the first one is y is equal to 3 times x minus 3 quantity squared minus 3. Remember to critique your function first before you start, because it tells you whether you have a minimum or a maximum. And then for my b, I'm going to have y is equal to a negative, and then x minus 1 and x plus 4. And again, remember, critique before you start, because it makes the process easier. So now you're going to pause and do problem number 2. So that is actually the end of all of our new material, but what I want to do now is review our quadratics a little bit, because they're very, very important in all of Algebra 2, and then if you move on to pre-calculus, it's really an important concept. So let's review our standard form first, because that was the first one that we learned. The equation is y is equal to ax squared plus bx plus c. And based on the formula, I know a lot of information. A is my vertical stretch or shrink, which means it makes the graph taller and thinner or shorter and fatter. If A is positive, it means that the graph points up, and if A is negative, it means that the graph goes down. Okay? The C is the Y-intercept. Okay? Another word for that is the initial value. And another part of that means that the x is 0, and then I have my y-intercept. Okay? If I look at a little graph of a parabola, okay, this is the y-intercept, so that is your c value, and then down here is my vertex. Okay, so the vertex and the y-intercept are not the same thing. So that's what we know from the standard form. The next form that we learned, we actually did it over a couple of days, was the vertex form. The vertex form is great for graphing, and it's easy to find the vertex. So for what the problems you just did, if I want to find the minimum or the maximum, if my equation is written in vertex form, I really don't have much work to do. All right, so the vertex form is y is equal to a times x minus h quantity squared plus k. The a is the same a. So notice there's an a in standard form. This is the same a. So a is the same a. And it has all of the characteristics. It's either a vertical stretch or shrink, it makes the graph go up, or it makes the graph go down. Okay? My vertex is going to have coordinates hk, and if you'll remember from the information that we did on our first exam, h is my horizontal translation, which makes the graph move either right or left. And remember, the value is always the opposite sign because it's inside the function. My k is my vertical translation, which means it's what moves the graph up or down. And because k is outside the function, it's always the sign that it says it is. All right. So there's my vertex form, and remember I do know that h is equal to a negative b over 2a, and k is going to equal f of h. So once I find the h value, I run it through the function, and that would give me the coordinates of my vertex. So the last form, we actually aren't going to use much, but we will manage its math. We will use it later in the year. It's called the factored form. And the factored form will have uses later, but for right now we're just going to use it to recognize the differences. All right, the formula for this is y is equal to a times x minus p and x minus q. All right, it's still the same a. So we're still managing the same a. It still has the same effect on the graph. The only difference now in this format is that p is an x-intercept and q is also an x-intercept, because if it is a second degree polynomial, it's going to have two x-intercepts most of the time. So if I look at a graph of a parabola, and let's say my parabola looks something like that, this is the vertex. On this graph, it also happens to be the y-intercept. The two are not always the same. But this might be your p-value, and this might be the q value. So I always put the opposite values into my equation, but it's actually kind of handy. We will use this more later in the year, but not right now, other than managing the math. If I want to find my axis of symmetry, remember that sometimes we call it an axis for short. I know that the axis is going to equal whatever the p is, add it to the q, and it divides it by 2, because it splits the difference between the two zeros. Okay? And once I know the axis, I also know of my vertex, I know the h. And so then all I would have to do is find k. All right? So those are the three forms that we've studied and kind of what their purposes are. This one we didn't get a purpose. We will get more information on that later. So that is your new information for today. Good luck doing your problems.